after considering the search algorithms, a second category, very important category of algorithms, is what we call sorting algorithms. Sorting is done a lot. When we look at computers, we try to initially sort lists, we try to add elements to a list. All these things are very important, and it is very important to understand well how sorting algorithms are used and how they are working. Now, this course is not about algorithms. There are different courses related to algorithms. In this case, we're looking at the general aspects of sorting algorithms, the principles, and of course, in follow-up courses related to algorithms, we will talk about these things in more detail. Now, when we look at the sorting, like I said, importance of sorting, sorting is done a lot in computers. And what it means is that we are putting a certain number of elements, a selection of elements, in a specific order. We can sort them from high to low, low to high. We can include numbers, strings, and other elements. I already said before that we have to be careful when we look at sorting. What is the value of a number? Is it considered to be a number? Is it considered to be a string? So there are different sorting mechanisms going on. And it's also very important to understand that when we look at different countries, they may have different alphabets, and their sorting may be different. A good example that I've seen here many times is the difference between the Czech alphabet and, for example, an English or an American alphabet. Now, not all is about English. There are other languages. And when you're programming into these different languages, you have to be careful that the sorting is done properly. Now, sorting, since it's so important, a lot of sorting algorithms have been developed. The simplest algorithm was what's called the bubble sort, and there are also extremely complex algorithms to make sorting, let's say, faster and more efficient. Now, there are over 100 sorting algorithms that have been described, each with its specific application and efficiency. Now, if you want to apply sorting, you can find the best algorithm. You don't have to program it yourself anymore. Those procedures exist and you can use them as such. And of course, you may try to find a better sorting algorithm, but first have a look at those 100 existing sorting algorithms. It would be, let's say, sad if you would lose the time to look into a new algorithm, think you made something, and basically it already exists. Now, there are different parameters that we have to consider. Some algorithms may be easy to implement. Some others work faster, or they are adjusted to a specific computer structure and they are optimizing the sorting to it. So computer structures may be very important because when you look at the sorting, the computer itself, the architecture of the computer also may have an effect on how fast sorting works. Now let's start with the simplest algorithm for sorting. A lot of people know this or have been working with it or encountered this, is the bubble sort. The bubble sort is a very simple algorithm. It became very popular because it's very easy to program. Unfortunately, when we have large set of numbers, the bubble sort is not always the best way to sort elements. Now, like I said, very inefficient when the number of data increase. And when we look at the amount of data we are working with today, it is very important that we have more efficient algorithms. Now, it's a good example to learn how these algorithms work. And first thing, of course, is to explain why we call it bubble sort. And when you look at a list, a set of numbers, it's called bubble sort because the largest number seems to bubble up, comes out of all the data, and it ends up, let's say, automatically at the end of the series. That's where the bubble came from. There were other names for this algorithm, but today everybody knows it as the bubble sort. Now, how does it work? We take the first number and we compare it with the next in line. And if the number is lower or higher, when the number is higher, we switch it. And we continue. And we move this number, we do this with all the numbers, until we find the largest number at the end of the data line. So basically it bubbles up. And then we do it on n minus 1. We start again from the beginning. We do it on n minus 2 until we reach the last element. So basically we're doing this step by step, and we see that at the end, the last element will always be the largest. The second before the end is the second largest, and so on. So we always have less numbers to evaluate. When we look at the description of bubble sort, first we go from the left to the right through a set of numbers and compare each number with the next one. And we exchange the numbers if they are not ordered as they should be, ascending or descending, depending on the goal of the sorting. We will look into this in an example, so you will clearly see how this works. The second element is go through the line again until you reach number n minus 1. We do not have to continue to n because the last number automatically is the highest or the smallest number in the row. We repeat this, and since you already ordered 2 elements, you can stop at n minus 2. And we repeat this, and once you reach n, we have to pass through the last n minus 1 numbers, and at n plus 1, everything is finished. So basically, we stop and we do the last number, which automatically will be in its place. Let's have a look at an example. We have the numbers here 44, 35, 23, 18, 15, and 11. Basically, they're inversely ordered, but that's not a problem. Now, the first thing we do is we compare 44 with 35. Since 44 is higher than 35, I switch 44 with 35. And now I look at 44 being in the second position, and I compare it with 23. And I see 44 is smaller than 23, so I change 44 and 23. And we put 23 on the second place, 44 is on the third place, and now we compare it with the next number, which is 18, and we switch it again. So now in the beginning we have 35, 23, 18. 44 is on the fourth position, and we compare it with the fifth number, which is 15. So we switch it again, and basically we find 44 in the fifth position. We compare it with 11, and basically we have the first calculation, the first changes, the first switches, and you see that the 44 bubbles up at the end of this series. Now we can look at all the other steps. We have the following steps. So basically we do the same thing with the 35. We compare it with all those numbers. We compare it with 23, 18, 15, 11, and it ends up just before 45. So now we have two ordered numbers, 35 and 44, and we do the same now with the 23. So the 23 goes to that fourth place now, and we see 23, 35, and 44 are ordered. Now we look at the following number, the remaining number. We always start with the first one in the series, which is 18, and then we continue until we have the 11 in place. Basically, we have the 15, which we put in place, and the last number we don't have to do anymore because automatically this will be the lowest number. We write the pseudocode for the bubble sort, and we have real numbers larger or equal than 2. So when we have less than 2 numbers, of course, we will not sort. When we say for I equal to 1 to n minus 1, we do it again, a second loop for I to 2 from 2 to n minus 1. And when they are, let's say, having a different order, I have to for j from 2 to n minus 1 here. And if aj is larger than ai, then we interchange aj with aj plus 1. So we move them around. And finally, at the end, we find this set in an increasing order. We also can consider a different sorting procedure, which is in fact faster. We will see later that it is faster. And we find that the insertion sort is basically a different sorting algorithm. Now we divide the list in a sorted list of one element and a not sorted list of n minus 1 element. Now the first element of the list is the first element of the sorted list, while the others are part of the unsorted list. So I have basically a set of numbers. I take the first number, I take it out, and I say this is my first sorted list, and all the other numbers are not sorted. Now we take the first element of the not sorted list and compare it with the number in the sorted list. And when it is smaller, I put it in front. I move it to the first place. If not, I put it at the end of the sorted list. And now we have two sorted elements in the sorted list and n minus 2 elements in the not sorted list. We take again the first number of the not sorted list and we compare it with the two elements of the sorted list. Now there are three possible positions. The new number is the smallest, is between the two existing elements, or is the largest. You put it at its relevant position, and now the sorted list contains three elements and the not sorted list n minus 3. And we continue this procedure until the size of the sorted list is equal to the total number of elements in the list. And of course, the unsorted list will be empty. All the elements have been sorted. So that's basically the principle of insertion sort. Let's have a look how we can do this as a principle, how this works. Basically, I have those numbers, and I have on one side the sorted data. I have a list in the middle. I have smaller than x of y, larger than x of y, so where we are putting the numbers. We have x of y, which we are in fact taking from the unsorted list, and we're integrated in the sorted data. Now, the sorted list when we start is very simple. The sorted list is only the number 44. So basically it's very simple. And what we do now is we look at the x number, the xy, and we put it on the new place. So here we only have one, so we are going to take the 35. We're putting it at the right place, so we put it before 44. Now with the list here, it's quite easy because we always put it in front, but basically those numbers may be completely in a different order. Now let's have a look at an example step by step. So we have the numbers here. I take the first element of the sorted list and the unsorted list. So we have the 44, which is there. Now I take the first element of the unsorted list and I put it there waiting to be placed in the sorted list. And I put it on the relevant position, in this case, the first position. And we see we have now two elements in the sorted list and four elements in the unsorted list. We continue with 23, we put it in between, and then we put it on the right position in the sorted list. So we have three sorted elements and three unsorted elements. And we continue this until we have, in fact, the totality of the numbers that we get at the end of the series. So the unsorted list then becomes equal to 0. So that was the insertion sort example, and we can also write the pseudocode. So the pseudocode is a little bit more complex, and you can find it here, how to calculate it and how to find the location or the position, the list with the ordered numbers. So that's what I wanted to tell you about the different sorting algorithms. Sorting is very important. And in our next video, we will talk about a special type of algorithm, which is the greedy algorithm. You're doing a great job, and I'm looking forward to seeing you in the next video. Thank you, and bye-bye.